In 1977, NASA embarked on one of the most audacious missions in the history of space exploration, the launch of two robotic spacecraft, Voyager 1 and Voyager 2, designed primarily for flybys of the outer planets. These spacecraft exceeded all expectations. Originally intended for a 4-year mission, both Voyagers continue to operate nearly 5 decades later, transmitting data from the fringes of interstellar space. Voyager 1, now over 25 billion kilometers 15 billion miles from Earth, holds the distinction of being the farthest human-made object from our planet. But longevity in space does not come without hardship. In 2025, a new crisis emerged that threatened to end the mission of Voyager 1. A critical set of thrusters essential for maintaining its orientation, or attitude, appeared to be failing. These thrusters are fundamental to ensuring that the spacecraft's high-gain antenna remains precisely pointed at Earth. Without this alignment, Voyager 1 would be unable to communicate, rendering it a silent relic drifting through space. To maintain orientation, Voyager 1 uses small thrusters that control pitch, yaw, and roll. The roll axis is especially crucial because it ensures the spacecraft rotates correctly to stay aligned with a designated guide star, essential for navigation. There are 2 sets of thrusters for each axis, primary and backup. In 2004, the primary roll thrusters failed to function, likely due to the failure of 2 small heaters that kept them warm in the frigid vacuum of space. At the time, NASA engineers at the Jet Propulsion Laboratory JPL assessed the situation and opted to switch over to the backup roll thrusters. These backups remained operational and performed admirably for more than 2 decades. They probably didn't think the Voyagers were going to keep going for another 20 years, remarked Kareem Badri, the Voyager mission manager at JPL. It was a practical decision given the spacecraft's age and distance. However, by early 2025, the backup thrusters began showing signs of wear. Engineers noticed that the thrust levels were decreasing and telemetry data suggested a clog forming in the fuel lines. The likely cause was a gradual buildup of residue from decades of continuous use. If these backup thrusters were to fail, Voyager 1 would lose its ability to maintain antenna alignment, severing the only communication link with Earth. This looming failure coincided with a scheduled communications blackout. From May 2025 to February 2026, Deep Space Station 43 DSS-43, located in Canberra, Australia, was scheduled for essential upgrades. DSS-43 is the only antenna in NASA's Deep Space Network powerful enough to send commands to Voyager 1. The temporary loss of this capability added urgency to an already critical situation. If the backup thrusters failed during this upgrade window, engineers would be unable to send corrective commands, dooming the mission. Faced with the imminent threat, JPL engineers made a bold decision: attempt to revive the primary roll thrusters that had been considered inoperative since 2004. This was no small feat. The assumption for over 2 decades was that these thrusters were permanently unusable due to the failed heaters. But a new hypothesis emerged. Engineers theorized that the issue might not have been a total system failure but rather an electrical circuit disturbance that had flipped off the power switch controlling the heaters. If they could remotely reset this circuit, the heaters might come back online, allowing the thrusters to warm up and fire safely. However, the risk was immense. If the thrusters activated while still too cold, the sudden release of pressure could rupture the fuel lines or damage the spacecraft. Furthermore, the reactivation process required precise timing and coordination. If Voyager 1's orientation drifted too far from the guide star during the sequence, its autonomous software might attempt to fire the cold thrusters as a corrective measure, causing irreparable damage. The engineering team meticulously crafted a series of commands to test their theory. They designed a sequence that would gradually warm the thrusters, closely monitor the spacecraft's attitude, and avoid triggering any emergency response. On March 20, 2025, the commands were transmitted to Voyager 1. Due to the vast distance between Earth and the spacecraft, it takes more than 23 hours for a signal to reach Voyager and another 23 hours for a response to return. The team had to wait anxiously for nearly 2 full days to learn the outcome. When the data finally arrived, it confirmed their hopes. The heaters had turned back on, and the temperature readings of the primary roll thrusters began to rise. Eventually, the thrusters themselves responded, coming back to life after 21 years of dormancy. It was such a glorious moment, said Todd Barber, the mission's propulsion lead at JPL. These thrusters were considered dead, and that was a legitimate conclusion. It was just that one of our engineers had this insight that maybe there was this other possible cause and it was fixable. The revival of the primary roll thrusters provides a vital lifeline for Voyager 1. It not only allows the spacecraft to maintain its orientation and continue sending data, but also offers redundancy. Should the backup thrusters fail completely, engineers now have a functioning alternative. This breakthrough ensures that Voyager 1 can continue its mission, at least for a few more years. This wasn't the first major challenge Voyager 1 faced in recent years. In late 2023, the spacecraft experienced a 5-month data outage. A corrupted memory segment in its flight data subsystem made it impossible to interpret the information being transmitted. NASA engineers devised a workaround to bypass the corrupted section and resume normal data flow.
By April 2024, the spacecraft was once again sending usable engineering data. By May 2024, all 4 of its science instruments were back online. In February 2025, NASA made another tough decision to preserve Voyager 1's dwindling power reserves. Engineers shut down the cosmic ray subsystem, one of the spacecraft's scientific instruments, in order to conserve energy. This move ensured that other key instruments, such as the low-energy charged particle detector, could remain operational. According to projections, this instrument is expected to continue providing valuable data through the end of 2025. Despite the power constraints and aging hardware, Voyager 1 continues to produce groundbreaking science. It is currently the only spacecraft sending back data from interstellar space. The spacecraft is measuring the density, temperature, and magnetic field strength of the plasma beyond the heliosphere, the bubble of space dominated by the solar wind. These observations are invaluable for understanding how our sun influences the space environment and for identifying the true boundary between our solar system and the rest of the galaxy. Beyond its scientific contributions, Voyager 1 serves as a test bed for future interstellar missions. The spacecraft's longevity provides insight into the design and durability of long-duration probes. The lessons learned from its operation have already influenced the planning of future missions destined to leave the solar system permanently. Moreover, the recent upgrades to NASA's Deep Space Network, including those at DSS-43, will benefit upcoming projects such as the Artemis lunar missions and planned explorations of outer solar system bodies. In many ways, Voyager 1 has become more than just a spacecraft. It is a symbol of human curiosity and resilience, a machine built in the analog age that continues to thrive in the digital era. Its journey, propelled by ingenuity and determination, reminds us of what is possible when exploration meets perseverance. As we look ahead to the 2030s, engineers remain committed to extending the Voyager mission for as long as possible. Each year brings new challenges, but also new opportunities for discovery. For now, thanks to a bold and risky maneuver, Voyager 1 continues to whisper from the stars, delivering data from the final frontier. Thank you for watching this extraordinary story of survival, science, and spaceflight. Be sure to like, subscribe, and tap the notification bell so you never miss an update from the farthest reaches of human exploration. Until next time, keep looking up.